All right, we're talking about quadrilaterals today. Quadrilateral is a closed figure formed by four segments intersecting at their endpoints. Now that's a little bit more complicated definition than you might need, and the reason for that is it's just reiterating part of what the definition of a polygon is. An easier definition might just be a four-sided polygon. So if you remember everything that a polygon is, all of that would still apply, and it has four sides. Okay, right here on A, these are examples of things that are quadrilaterals. And on B, these are things that are not quadrilaterals. And the reason these are not quadrilaterals, while they have four segments each, or not technically segments in some cases, but it appears they have four sides of some sort, they don't match the definition of polygons. This one is not closed. These ends need to meet up to make it closed. Right here, these segments are not intersecting at endpoints only. They're intersecting somewhere in the middle of the segments as well. And this one has a curved side to it. And segments are always straight. So any kind of polygon, all the sides are straight edges. They're segments. And so a quadrilateral has to have straight edges as well. These are all examples of quadrilaterals. Okay. Now specifically today we're going to talk about parallelograms, which are a type of quadrilateral. A parallelogram is a quadrilateral in which opposite sides are parallel. So right down here, here's an example of a parallelogram. Notice it fits the definition of a quadrilateral. It is a four-sided polygon. And notice that these two sides have been labeled parallel with these arrows. And these two sides have been labeled parallel with those arrows. So this is an example of a parallelogram. Alright, the parallelogram at the right has four vertices. They are M, N, P, and Q. Remember, a vertex is the endpoint of a segment where it intersects another endpoint of a segment. It's kind of like the corners of the shape. So N is a vertex, M, Q, and P. Those are the vertices. Vertices is just a plural word for vertex. Okay, we would name this, and when you name a parallelogram, you use this symbol. Just kind of like we do when we name a triangle, you put the triangle symbol in front. If you name a parallelogram, you draw this parallelogram symbol. And then we're going to write all four letters, and you can put them in a lot of different possible orders. What is important is that they go in an order around the figure. And it doesn't matter whether you go clockwise or counterclockwise. It doesn't matter which point you start at. So I could call it NPQM. I could call it NMQP. I could start at a different point. I could say PQMN or PNMQ. Any of those are acceptable names. This particular problem, they decided that we want to name it MNPQ later on, so we'll just go with that name for now. What you cannot do when you're naming the parallelogram is jump across the figure. So I can't call it NPMQ. I can't jump from P to M. Wherever P is in the name, N and Q got to come before it and after it. One's got to be in front of it and one's got to be after it because it's got to flow around the figure one way or the other. Alright, the opposite sides of triangle MNPQ, and I might have alluded to this earlier when we were talking about the fact that for it to be a parallelogram, the opposite sides have to be parallel. These sides are opposite each other, and these sides are opposite each other. So line segment NP and MQ, those two sides are opposite each other. And then line segment MN and line segment QP are opposite each other. Okay, the opposite angles of parallelogram MNPQ are angle M would be opposite angle P. They're on opposite sides of the parallelogram. And then angle N and angle Q are opposite each other. Okay, consecutive angles of parallelogram MNPQ are. Now consecutive, remember when you're naming it, you have to go around the figure, either clockwise or counterclockwise. So just imagine yourself going around the figure. Consecutive angles are angles that you would run into consecutively, one right after the other. So as I'm going around here, if I'm going this way, after N comes P. Angle N and P would be consecutive angles. Now, what if I was going the other way? Then right after N would be M. N and M are consecutive angles. Okay. Now, we already said that angle P was consecutive with angle N. What else is it consecutive with? It's consecutive with angle Q. Angle P and angle Q are consecutive angles. And the last one we have not mentioned yet is the combination of angle M and Q. And basically, if you are still confused by what a consecutive angle is, if you know how to name the sides with the segment names, like we did earlier, if you took each segment, the two endpoints of that segment are consecutive angles. So here's line segment NP is one side, angle N and angle P are the endpoints of that segment. Those angles would be consecutive angles. Here's a side, line segment PQ. The endpoints of that segment are P and Q. Well, angle P and angle Q would be consecutive angles, and so forth. Alright, this particular part of the notes was written in a way that it was supposed to be interactive, but I'll just go through this with you. Using parallelogram MNPQ, what conjectures can you make about the following? Well, we already know that the definition of a parallelogram is that the opposite sides have to be parallel. And notice they've already been marked parallel for us. So the first thing is opposite sides are parallel. Something else you might not know about a parallelogram yet, and you might be able to look at the picture and think it's possible, is that in all parallelograms the opposite sides are also congruent. Okay, in all parallelograms, opposite angles are also congruent. Let me start marking this stuff in the picture here. Not only are these parallel with the arrows, but I'm going to mark them congruent as well. Not only are these parallel, but they're congruent. Mark those congruent. And then opposite angles we said are congruent. So angle M and angle P are congruent. And angle N and angle Q are congruent. Opposite angles are congruent. And then one that would be hard to mark in the picture, but consecutive angles are supplementary. And you should be able to figure that out using same side interior angles, which we've learned about this year. Remember, these sides, opposite sides are parallel, so we have parallel lines. Here's a transversal. This angle and this angle, those are same side interior angles. And for any of you that have a hard time seeing it, if you extend the parallel lines, extend this side as the transversal, you hopefully can see the same side interior angles right here. And we learned a long time ago that when lines are parallel, same side interior angles are supplementary. You got the same situation going on over here, parallel lines, transversal, same side interior angles. And if I turn the paper, parallel lines, transversal, same side interior angles, parallel lines, transversal, same side interior angles. So we have a lot of supplementary angles there. All of the consecutive angles are supplementary to each other. Alright, so those are things that are always true about every parallelogram. Those are things we're going to want to memorize and use as we move forward. Okay, when polygons have more than three sides, they have diagonals. A diagonal is a segment joining opposite vertices in a polygon. So for example, in this figure down here, opposite vertices are A and D. Diagonal would join those two together. It's a segment that connects those two endpoints. Angle B and C, those are opposite each other. If I drew a segment from one to the other, that's a diagonal. So those are the two diagonals of that figure. Notice down here where it asks you to list the diagonals, it's already been filled in. Line segment AD and line segment BC are the diagonals for that particular figure. We did the other stuff earlier. The vertices are A, B, C, and D, each corner. The name, though, notice I said A, B, C, D, but when you name it, you wouldn't be able to say it in that order. These are separate, so the order doesn't matter. But when you're naming the entire figure, you got to go to an order that goes around it. So A, B, D, C. You could not call it A, B, C, D because that would jump across the figure. Now notice we didn't put a symbol out here in front because this is a quadrilateral, but we don't know it's a parallelogram. We don't know that the opposite sides are parallel to each other. So no parallelogram symbol, you just put the 4 vertices when you're naming the quadrilateral. And the opposite vertices A and D, and opposite vertices B and C. Alright, let's jump over here. What are the vertices of this figure? I see S, I see D, I see G, and I see O. Those are the 4 corners of that figure. Those are the vertices. Now when I name it, remember I can start with any point I want, and I got to go around the figure, either clockwise or counterclockwise, doesn't matter. So if I just start with S and go clockwise, S, G, O, D. That would be one possible name for that figure. Okay, opposite vertices. D and G are opposite each other. S and O are opposite each other. Okay, remember for a diagonal, you just connect the opposite vertices. So, if I connect D and G, I get a diagonal. And the name of that, the diagonal is a line segment, so that would be line segment DG. The other diagonal would connect the other opposite vertices, S and O. So if I draw a segment from S to O, that's a diagonal. And the name of that one, line segment SO. And hopefully this concept's simple enough. We're going to skip this part over here and move on. Okay, remember the word bisect. We've used that several times this year. It means to cut into 2 equal parts or split into 2 congruent halves. Well, in a parallelogram, the diagonals will bisect each other. In every single parallelogram, the diagonals bisect each other. So what that means is I have this diagonal. When I draw the other diagonal through it, it's going to split it right at its midpoint and split it into 2 congruent parts. So this diagonal gets split into 2 congruent parts. Well, the same is true for the other diagonal as well. This diagonal is split by the other diagonal into 2 congruent parts. They are both bisecting each other. So in every single parallelogram, you will end up with this situation right here, where this diagonal is split into 2 congruent halves, and this diagonal is also split into 2 congruent halves. So there's something else we just learned. So here are the things to summarize that we've learned about all parallelograms. These 5 properties are the things you're going to want to memorize and use. The opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Hard for me to mark on the picture. And the diagonals bisect each other. I showed you a picture of that up here. If I draw it in here, it'll be challenging to do. But those are 5 things that we know about every parallelogram. Alright, so let's use all this information that we've learned about parallelograms and see if we can answer some questions and solve some problems. Okay, example 3. Complete each statement regarding the parallelogram below. First, name the parallelogram. We name a parallelogram. Don't forget to use your parallelogram symbol. And then we're going to give the 4 vertices in order going clockwise or counterclockwise. A, B, C, D would be the most common probably just because of the order of our alphabet and the fact that it is possible here. Alright, line segment AB is parallel to, well remember opposite sides are parallel, so the side opposite this that's parallel to it is line segment DC. line segment DA is opposite line segment CB. So not only are they parallel, but they're also congruent. Remember, opposite sides are congruent. So line segment DA is congruent to line segment CB. I'm going to go ahead and mark these as well. AB was parallel to DC, and we said line segment DA is congruent to line segment CB. Alright, angle CDA, this angle right here, is congruent to, well, remember, opposite angles are congruent. So the angle opposite this one is going to be congruent to it. So that would be this angle down here, which could be either named angle CBA or angle ABC. Does not matter which one. But make sure that B is the middle point, the middle letter. And make sure you don't just call it angle B, because there's more than one angle at that point. If you just call it angle B, we won't know which one you're talking about. So we need to name it with 3 letters, either angle ABC or angle CBA. And then line segment DE, notice line segment DE is part of this diagonal. And remember, the diagonals bisect each other. So this diagonal here is going to get split into 2 congruent halves. So line segment DE is congruent to line segment EB or BE. Alright, let's look at example 4. If ABCD is a parallelogram, the measure of angle A is equal to x, and the measure of angle D is equal to 2x minus 3, find the value of x. The first thing I would suggest that you do is draw a picture so we can make sure we can see how these things are going to relate to each other. So I'll draw what looks hopefully like a parallelogram. And remember, when we name it, A could be at any of these, but once you decide where A is going, you got to either go clockwise or counterclockwise around when you're naming. So A, B, C, D. Make sure you're not jumping across when you're labeling. Otherwise, that's going to throw off the relationship of things, and you're going to end up getting your answer wrong. All right, now let me label the picture with the information. Angle A is x, and angle D is 2x minus 3. So the reason the picture was helpful is now I can see whether those angles are opposite or consecutive. And hopefully you can recognize these are consecutive angles. Angle A and C would be opposite. Angle A and D are consecutive. And we learned that with parallelograms, consecutive angles are supplementary. Remember, supplementary means that they have a sum of 180. They add up to 180 degrees. So if I were to add these 2 angles together, I know it'll equal 180. So that's how we set up the equation, and now we should be able to solve for x. So we combine like terms right here. We got 1x plus 2x is 3x's. Then I want to get x by itself. First thing, get rid of the constant. It's being subtracted, so we do the opposite and we add it. Oops. What in the world am I doing? I don't know why I wrote 183 earlier. Getting ahead of myself. We're bringing down that 180. We added 3 to it, so that'll be 183. Sorry about that. And then we got to get rid of this 3. X is being multiplied by 3, so we divide by 3. And 183 divided by 3 is 61. Alright, let's look at example 5. Alright, XYZW is a parallelogram with diagonals, line segment XZ and line segment YW, that intersect at point A. If the distance from X to A is equal to 3m, and the distance from Z to A is equal to 5m minus 4, and the distance from Y to W is equal to 10m, find m. Just like on the last time, the first thing I would do is draw a picture so we can see how everything relates to each other. So, let's draw a parallelogram, label it X, Y, Z, W, and it says it has diagonals XZ and YW that intersect at point A. So that point right there where they intersect, we're going to label that A. Okay, now let's put all this information into the picture that we can. The distance from X to A is 3m. the distance from Z to A is 5m minus 4. And the distance from Y to W is 10m. Now that's being split into two parts, so it can be a little tricky to label. I'm going to do it like this to show that that 10m is labeling this whole thing. Okay, let's see how we can figure out what m is here. All they've given us is diagonals and parts of diagonals. So remember, the one thing that we learned about the diagonals of parallelograms is that they bisect each other. So this diagonal is split into two congruent parts, and this diagonal is split into two congruent parts. Well, we just said these two parts are going to be congruent, and they gave me expressions for both of those that contain m. So I should be able to set up an equation using those. These two parts are congruent. When things are congruent, we set them equal to each other, because that means they have equal measures. I do not need that 10m to be able to solve this problem. That is a distractor. It is unnecessary information. So let's solve this problem. I don't want m on both sides, so I'm going to subtract 3m to get rid of it on one side. Now over here I got 0. Make sure you don't just leave off that side of the equation. You gotta keep the equal sign. You gotta keep both sides of the equation, even if it's 0. Now we want to get m by itself. I'm going to move the constant. 4 was being subtracted, so we do the opposite and we subtract it. Or excuse me, we add it. And then m is being multiplied by 2, so we do the opposite and we divide by 2. And we find out m is 2. Alright, 6, 7, and 8. For each parallelogram, find the values of x, y, and z. Alright, so we need to think about those 5 things that we learned about parallelograms and apply those. So, on 6, if I want to find x, I notice I have this 80 degrees, and these are opposite angles, and we learned opposite angles are congruent in a parallelogram. So I know that's 80 degrees. Okay? If I want to find z, these angles are consecutive angles, and we learned that in a parallelogram, consecutive angles are supplementary. So they add up to 180. So 180 minus 80 is 100. So I know z is 100 degrees. Now you can find y a couple of different ways. One way you could do this is we have opposite angles are congruent. And so if that's 100, this is 100. You could say consecutive angles are supplementary. So if this is 80, this would have to be 100. And then this right here, the y and this 100 degree angle, that's a linear pair. They're supplementary. So they add up to 180. So 180 minus 100 is 80. So that's one way you could go about getting your answer. A quicker way might be to remember that because this is a parallelogram, these lines are parallel to each other. Here's a transversal. These angles are alternate interior angles. And we know that when the lines are parallel, alternate interior angles are congruent. So if this is 80, this would have to be 80. So lots of different ways you could come up with. You could also use parallel lines, transversal. These are corresponding angles. So a lot of different ways to do it. Just use what you know and try to figure it out. Okay, let's figure out what these are. Okay, first off, when you have a parallelogram and you draw this diagonal through here, it splits that parallelogram up into a couple of triangles. And we know that in a triangle, the 3 angles in a triangle add up to 180 degrees. So I could find this angle over here if I want to, but I don't have to. It just depends on the process I want to go through. But right here, these are opposite angles, and opposite angles are congruent. Remember, in a parallelogram, the opposite sides are parallel. So think of parallel lines. Here's a transversal. These angles are alternate interior angles. So if this is 35 degrees, this is 35 degrees. And even though I didn't use the fact that the 3 angles in a triangle add up to 180 earlier to find this angle, I can use it now to find x because we have a triangle down here. And we now know 2 of the angles. So 120 plus 35 is 155. And 180 minus 155 is 25. So x is 25 degrees. Another way you could do it, remember the consecutive angles are supplementary. So that 120 degree angle and this entire angle down here have to be supplementary. So if this is 120, this would need to be 60. Because 120 plus 60 would be 180. So if I know that this is a 60 degree angle that's split into two parts, I know that the whole thing's 60, this part's 35. I can subtract that from 60 to find out what's missing. So there's another way you could get the same answer. Alright, let's look at number 8. Alright, let's see what we got. Well, first off, right here, these angles are a linear pair, so they have to be supplementary. So if this is 70 degrees, this has to be 110, so that they can add up to 180 degrees. You can do your subtraction if you need to. 180 minus 70 is 110. Okay. Parallel lines, transversal. These are alternate interior angles. And so if this is 30 degrees, X is 30 degrees. Okay. So how can we find Y? Well, we know that this angle is 30 degrees. And if this is 110, these angles right here are vertical angles. This would have to be 110. And remember that the three angles in a triangle add up to 180. So right here you have a triangle. You know this angle is 110, this angle is 30. We can add those together and subtract that from 180 and find out that angle Y would have to be 40 degrees. Alright guys, one more problem and we're done. Alright, WXYZ is a parallelogram, and the measure of angle ZWX is B, and the measure of angle WXY is D. Find the values of A, B, C, and D. Alright, well, A is not that difficult. A is labeling a part of a diagonal. And remember, in a parallelogram, the diagonals bisect each other. So this diagonal is being bisected into two congruent parts. So if this is 15, A is 15. Okay? Now, B is labeling this angle. And it is opposite this angle. So remember, in a parallelogram, opposite angles are congruent to each other. The only thing we'd have to do here is this opposite angle is not given to us in a plain number. It's been split into two parts, and they gave us each of the two parts. So we just have to add those together to find out what that whole angle is. So I know that this angle is 49 degrees, so B is 49 degrees because they're opposite angles. They are congruent to each other. Okay, C is labeling this side over here. Remember, in a parallelogram, opposite sides are congruent. And these two sides are opposite each other. So I know they're congruent. So I set them equal to each other. And then just solve for C. And finally, D. I don't have the angle opposite D. But remember that consecutive angles are supplementary. So this angle and this angle are consecutive angles. So since this is a 49 degree angle, I can take 180, subtract 49, and find out what D is. So D is going to be 131 degrees.